Welcome to Classwork 1.1. We're going to start right with example 2 right here. Hopefully you recall these symbols right here, this upside down U and this U. From your previous algebra classes, hopefully you recall that the U stands for union. The upside down U stands for intersection. And if you forgot, that's okay. I'll quickly go over it. So we're looking for, on letter A, the intersection of those two sets of numbers. So we're going to draw a number line like that. I'll put 1 and 4. And it says parentheses. So I just put a parentheses here and here, and I will shade. Now recall parentheses means non-exclusive, so we can't count 1 and 4. Now in red, I'll do 2 and 8. 2 should be somewhere here. 8 would be out here. And these are brackets. So for brackets, recall that that means that is inclusive. So I'll shade like that. For intersection, intersection basically means we're looking for the overlap. So here we can see the overlap region is here. So we're going to write that as the answer. For A, it's bracket 2, comma 4, parentheses, meaning we include 2, we exclude 4. For B, it's the exact same values except it's a union. Now for union, you have to understand union means or, meaning we want numbers that satisfy either one of those sets of numbers. So because it's an or, I think of it as take everything. Meaning everything that's shaded red or blue we want. So just take the whole actual number line that's shaded, which would be 1 to 8. So 1 parentheses, 8 bracket. And right there are your two answers. So let's try another example here. Here's a number line. Let's put down 1 and 3, bracket, bracket, we'll shade. And then 2 and 6 is a parenthesis, so we'll do that. For A, notice how right there, that's an intersection. An intersection, again, means overlap. So we're going to write 2 to 3. 2 non-inclusive, 3 inclusive. B, that's a union. Union is another word for or, meaning as long as it satisfies either of those conditions, we're good. So take the whole thing we shaded, which is inclusive 1, 6, exclusive. And now we're done. For our next example, this is going to be a quick review of Algebra 1. You guys learned this a long time ago, Algebra 1 or Algebra 2. It's solving an inequality with an absolute value. Now you might recall this technique. For our next example, we're going to talk about solving an absolute value inequality, and you probably did this back in Algebra 1, Algebra 2. So I'll quickly just jog your memory here. There are typically two inequalities we have to solve. The first one is the regular one without any absolute value, meaning this is our first condition. The absolute value does nothing. So you write x minus 4 is less than 3. Now the other thing that could happen is absolute value actually does matter, meaning we just write x minus 4 is greater than negative 3. And then we solve that. So x should be less than 7, and x should be greater than 1. So if we were to actually graph this answer, we would say all numbers between 1 and 7, like this. On interval notation, we'd write 1, 7. So that's the basic idea. So again, over here you have your standard. Over here, we just change the sign. So that's like the Algebra 1 surface level way of doing it, and we are going to talk about it more deeply in pre-calc. But first, I want to make sure mechanically you guys can do that. So let's try a slightly harder example here. This next example, we're going to do the same thing, except we're going to flip it around just to make it easier for ourselves. You don't have to do this, but I do think it makes it easier for most people. So notice how I just reoriented. Now I'm going to do the exact same thing, draw a vertical bar. Here's our first inequality. Basically, just take off the absolute value. And the second one's going to be 5 minus 2x. You flip the signs here, so less than negative 7. So we solve this. Negative 2x is greater than 2. Divide by negative 2. If you divide by a negative, the sign will flip, so less than negative 1. Do the same thing here. Negative 2x is less than negative 12. Divide by negative 2. The sign will flip, so greater than 6. And there you have it. It's greater than 6, so I'll shade to the right. And it's less than negative 1, so we shade to the left there. And our answer is negative infinity to negative 1 union 6 to infinity. So that's another example of an absolute value inequality. And again, notice how this is just like the surface level. In this next problem, we're going to illustrate what's really happening in absolute value inequality.